that A cross B equals B cross A if and only if A is equal to B. This is an if and only if statement, a biconditional, which means we'll have to go forward and we'll have to go backward. I'm going to start off with the backward direction because that's going to be easier. It's going to be the shorter proof. So in the backward direction, think for a moment, what am I going to fill in that blank with? I need to suppose something if I'm working in a backwards conditional, the backwards part of this biconditional. So suppose the second part, the Q. We're going to suppose that A equals B. And then as an NTS, this isn't actually part of the proof, but more like part of your discussion. NTS stands for need to show. Our goal is to try to show that A cross B is equal to B cross A. And if I can do this, then I will have satisfied the backwards part of the biconditional. So let's start to see if we could do this. We need to show A cross B equals B cross A. So let's start off with notice. What is A cross B actually equal to? We hope it's equal to B cross A, but we're going to go see. Well, we said that A equals B, so with A cross B, I'm going to substitute B for that first part of the Cartesian product. So we have B cross B. Then I'm going to leave the B the same, but I'm going to replace B with something that it's equal to, namely A, because we suppose that A equals B. So what do we get? We get that A cross B is actually equal to B cross A. So that completes the backwards direction of the proof. Okay, let's try the forward direction then. In the forward direction, we're going to suppose that A cross B equals B cross A. That's the first part, the P. What are we going to want to show here? Do you remember? Now we're going to want to show the second part, the Q. We want to show that A equals B. And if we can do this, then we'll be good. Now in order to show that A equals B, this is two sets that we're hoping are equal to each other. So the way that I'm going to do this is I'm going to do a double containment proof. Double containment proof. So a forward direction, I need to show that A is a subset of B. Every single thing in A is in B. So let X be an element of A. Now X is an A. So let B, suppose B is non-empty. Let Y be any element of B. Now, because we took X from A and Y from B, we can say that X comma Y, the ordered pair, must be an A cross B. But remember, our assumption says that A cross B equals B cross A. So X comma Y is also in B cross A, because A cross B and B cross A are the same by assumption. Okay, now notice what we get. Where is X? Well, X is the first coordinate of this Cartesian pair, and according to this, this is coming from set B. So therefore, X is in B. So we took an arbitrary element from A and we showed that it's in B. So A is a subset of B. There we go. So we've got one set, one direction of the set containment. You might imagine what the second direction looks like, so why don't you pause the video and see if you can go in the backwards direction on your own. Assuming you paused and gave it a shot here, I'm going to go backwards, which means I'm going to need to show that B is now a subset of A. So let X be in B. Like before, I'm also going to let Y be in A. Now, because of the way that I chose these, I have that X comma Y happens to be an element of B cross A, because I chose something from B and I chose something that was in A. But by our assumption, B cross A and A cross B are the same thing. So X comma Y is also in A cross B. But then we have X comma Y and A cross B, so X, the first element of the pair, the ordered pair here, must come from the first part of the Cartesian product, which is A. So X is in A, and so we took an arbitrary X in B and we showed that it's in A, so we get that B is a subset of A. That completes the double containment proof, so therefore A equals B, and that completes the forward direction of our proof.